So AI agents are getting ridiculously good, right? And one of the coolest ways they tackle really complex problems is by actually writing code to figure things out. But there's a catch. That method can be super fragile. Think of it like a train on a single track. One tiny error, and the whole thing just goes off the rails. Well, a new research paper is proposing a much smarter, more robust way for an AI to think. And that's exactly what we're going to break down today.
Okay, so here's the game plan. First, we'll get into why current AIs can be a bit fragile in their thinking. Then, we'll introduce this new, more robust approach. After that, we'll dive deep into how it actually works, look at the test results to see if it's legit, and finally, peek into what this could mean for the future.
All right, first things first, let's talk about the core challenge here. The actual problem that researchers are trying to get their hands around with today's AI agents. It's a great question, isn't it? Why do these incredibly smart AIs sometimes just fall flat when a task gets really complicated? Well, as these researchers point out, it's not really about raw intelligence. It's about the process the AI is forced to use to get to an answer.
The method that's been the top dog until now is called CODACT. You can kind of think of it like an AI thinking out loud with code. It writes a little piece of code, sees what happens, writes the next piece, checks that, and so on, step by step. It's definitely powerful, but, and this is a big but, this one-step-at-a-time process has some pretty serious weaknesses.
Yeah, this one-track approach is what the paper calls fragmented and stalled thinking. Since it's just this one long chain, if the AI makes one little mistake or has a hallucination early on, that error just gets carried all the way down the line. The whole system just isn't very robust. It's brittle, it's fragile.
So to fix that exact problem, the researchers came up with this really fascinating new hybrid approach. They call it Tree of Code, or TOC for short, and it's built from the ground up to be way more stable and robust. And here is the fundamental shift in thinking. Instead of building a solution piece by piece, Tree of Code thinks up multiple, complete solutions from the get-go. And instead of following one single fragile path, it explores all these different paths at the same time. It's a total change from a single file line to a robust, multi-pronged attack. That's the core idea right there. And that brings us to the most important part of this whole paper. How does this Tree of Code thing actually work? Let's get into the mechanics of it, because this is where the genius of the whole method really shines through. This one diagram, figure 1 from the paper, it perfectly captures the entire concept. On the left, you see the old way, CODACT. It's just that one straight linear path. It's fragile. One little mistake and the whole thing can fall apart. But now, look at the right side. That's Tree of Code. It takes the problem and immediately branches out, exploring a whole bunch of different potential solutions at once. Those are the yellow blocks. It then tests them all in parallel. See the red blocks with the little trash can? Those are the ideas that failed. They get pruned away, just tossed out. But the successful ones, the green blocks, those get collected. And for the final step, the system holds a majority vote among all the successful green paths to produce the most reliable, robust final answer. It's like a self-correcting system that explores and learns from its mistakes in real time. So yeah, that single, fragile path of the old method, that's its biggest weakness. It's just not built to handle mistakes. So just to recap that beautiful process we just saw in the diagram, it explores a ton of different paths, runs the code for all of them at once, reflects on what didn't work and just throws those failures away, and then it gathers up all the winning solutions for a final vote. It's a much more dynamic, much more resilient way of getting things done. And that color coding is super intuitive, right? Yellow means the AI is still thinking, red is a dead end, and green means we have a winner. Now, this all sounds fantastic in theory, and the diagram looks great. But does this more complex, branching exploration actually lead to better results? Well, the researchers put it to the test. And boom, here's the headline result. Tree of Code was 7.2% more accurate than the absolute best version of the old CODACT method. Now, in the world of AI benchmarks, a jump that big is a massive deal. It's a huge leap forward. And digging into the actual data tells an even better story. Look at this. TOC is at the top. Not only did it get that awesome 81.6% accuracy, but look at the average turns column. It solved the problem in just 2.3 steps. That's less than half the time of its closest competitor. So it's not just more accurate, it's dramatically more efficient. So clearly, this is a significant step forward for building AI agents that are more reliable and, well, robust. But the paper doesn't just stop there.
It gives us this really exciting little hint about what's coming next. I love this. This is the direct quote from their conclusion. The authors themselves are saying that their current work, the stuff they haven't even published yet, is showing this method could be amazing for real-world applications. They literally tell us to stay tuned. That's confidence.
Which leaves us with a final, really fun thought. Now that we have a way for an AI to explore lots of different solutions to a problem, what's the first big, complicated challenge you think we should throw at it? Curing diseases? Climate modeling? Let us know your most ambitious ideas down in the comments. And of course, if you want to understand the next big idea in AI, make sure you're subscribed to VibeDoc. We'll catch you in the next explainer.